Hey everyone! In this video, we are solving a system of equations using the substitution and the elimination method. Let's go through it step by step. A system of equations is a set of two or more equations that share the same variables. Our goal is to find values for these variables that satisfy all the equations at the same time. There are three common methods to solve systems of equations: substitution, elimination, and graphing. In this lesson, we will focus on substitution and elimination. Let us take a look at an example. We have the system 3 times x plus 2 times y equals 8, 4 times x minus 2 times y equals 6. Our task is to find the values of x and y that make both of these equations true. We will explore different methods to solve this system. Substitution method. This method involves solving one equation for a variable and substituting that value into the other equation. Elimination. This method focuses on adding or subtracting the equations to eliminate one variable, making it easier to solve for the other. Let's take a closer look at the substitution method for solving a system of equations. This method follows 4 key steps. First, solve one of the equations for one variable in terms of the other. Next, substitute this expression into the second equation. Then solve for the remaining variable. Finally, substitute the value back into one of the original equations to find the other variable. This approach works well when one equation is already solved for a variable or can be easily rearranged. Let us go through an example. We are given the system of equations: 2 times x plus 3 times y equals 7, 4 times x minus 3 times y equals 5. First, we add the two equations together. Notice that positive 3 times y and negative 3 times y cancel out, leaving us with 6 times x equals 12. Now, solving for x, we divide both sides by 6. X equals 2. We now have the value of x. In the next step, we will substitute x equals 2 into one of the original equations to find y. Let's continue. Using the equation 2 times x plus 3 times y equals 7, we replace x with 2. 2 times 2 plus 3 times y equals 7. This simplifies to 4 plus 3 times y equals 7. Next, we subtract 4 from both sides. 3 times y equals 3. Now, dividing both sides by 3, y equals 1. So, the solution to the system is x equals 2, y equals 1. This means the two lines intersect at the point 2, 1. 2. Using the substitution method, we start with a system of equations. Negative 1 times x plus 2 times y equals 7. 3 times x plus 4 times y equals 15. To eliminate x, we multiply the first equation by 3 to match the coefficient of x in the second equation. This gives us negative 3 times x plus 6 times y equals 15. 3 times x plus 4 times y equals 15. Now adding both equations together, the x terms cancel out, leaving us with 10 times y equals 30. Now we can solve for y. Now that we have 10 times y equals 30, we solve for y by dividing both sides by 10. Y equals 30 divided by 10, which simplifies to 3. So we have found that y equals 3. Next, we substitute this value back into one of the original equations to find x. Now we substitute y equals 3 into one of the original equations. Let's use 3 times x plus 4 times y equals 15. Replacing y with 3, we get 3 times x plus 4 times 3 equals 15, which simplifies to 3 times x plus 12 equals 15. Next, subtract 12 from both sides. 3 times x equals 3. Finally, divide by 3 to solve for x equals 1. So our solution is x equals 1, y equals 3. Now that we have found both values, we conclude that the solution to the system of equations is 1 and 3. This means that the lines represented by these equations intersect at the point 1, 3. Now let's move on to another method for solving systems of equations: the elimination method. This method involves 4 main steps. First, we multiply one or both equations so that one variable has the same coefficient. Then we add or subtract the equations to eliminate one variable. Next, we solve for the remaining variable. Finally, we substitute back to find the other variable. This approach is especially useful when the equations are already aligned for elimination. Let's see how it works with an example. Let's apply the elimination method to solve this system of equations. We start with the two given equations: 2 times x plus y equals 5, x plus 5 times y equals 15. First, we express y in terms of x from the first equation. Y equals 5 minus 2 times x. Now, we substitute this into the second equation. X plus 5 times 5 minus 2 times x equals 16. Expanding the expression, x plus 25 minus 10 times x equals 16. Simplifying, negative 9 times x equals negative 9. Solving for x, we get x equals 1. Now that we have found x equals 1, let's substitute this value into our equation for y. From the equation y equals 5 minus 2 times x, we substitute x equals 1. Y equals 5 minus 2 times 1. Simplifying, y equals 5 minus 2. Y equals 3. So the solution to the system of equations is 1 and 3. We have now found both values, x equals 1 and y equals 3. Thus, the solution to the system of equations is 1 and 3. This means that the two equations intersect at the point 1, 3 on a graph. And that's how you solve a system of equations using the elimination method. And that's it. We solved the system and found the solution. If you found this helpful, don't forget to like, share, and subscribe for more math tips. See you next time.